Hello and welcome to my channel, Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. As usual in the book and in these videos, we'll start out with a list of keys to understanding, or KTUs, so that you can see on one page the most important things to understand about the concept. There are 5 keys to understanding for the concept of null hypothesis. Let's go through the list fairly quickly first, and then follow that with a detailed explanation of each key. KTU number 1 is stating a null hypothesis and an alternative hypothesis is the first step in our 5-step method for hypothesis testing. The second key to understanding is the null hypothesis, symbol H sub 0, is a statement of nothingness or absence. In words, it is stated in the negative. The third KTU is it is probably less confusing to state the null hypothesis as an equation or comparison formula. That must include an equivalence in the comparison operator using one of these: equal to, less than or equal to, or greater than or equal to. The fourth key to understanding is, if the equal sign is not to be used in the null hypothesis, start with the alternative hypothesis. The alternative hypothesis will point in the direction of the tail of the test. The fifth key to understanding is, the last step in hypothesis testing is to either reject the null hypothesis if p is less than or equal to alpha, or fail to reject the null hypothesis if p is greater than alpha. Okay, here on one page is the complete list of keys to understanding for the concept of null hypothesis. You may want to pause the video at this point and read them again. Then next, we'll go through a detailed explanation of each KTU. Our first key to understanding, KTU number 1, says stating a null hypothesis and an alternative hypothesis is the first step in our 5-step method for hypothesis testing. But what is hypothesis testing? Hypothesis testing and confidence intervals are the 2 main methods used in inferential statistics. In inferential statistics, we take a sample of data from a population or process and we calculate a sample statistic, like the sample mean or sample standard deviation. We then use the value of this statistic to infer or estimate the value of the corresponding property of the population or process. For example, the population mean or the process standard deviation. This 5-step method will be explained in detail in a separate video devoted to hypothesis testing. But briefly, notice that the hypothesis testing method begins and ends with the null hypothesis. Step 1 of the 5-step method corresponds to our key to understanding number 1, and step 5 of the method corresponds to our key to understanding number 5, as you'll see. In between, the method selects a level of significance, alpha, and calculates a value for p. Depending on when you are viewing this, there are or will be separate videos on the channel for alpha and for p also. The concept of null hypothesis can be confusing because it is a statement of nothingness or absence, and we're all accustomed to thinking about things that do exist. We would normally phrase the issue as a question or a positive statement. So why don't we start like that? Here are 3 examples. Is there a statistically significant difference between the means of these 2 populations? Or has there been a statistically significant change in the standard deviation of our process from its historical value? Or this experimental medical treatment has a statistically significant effect. Let's now state the opposite of the question or positive statement. This creates a negative statement that we can use as a null hypothesis. For example, if our question is there a statistically significant difference between the means of these two populations, our null hypothesis would be there is no difference between the means of these two populations. Note that we don't normally include the words statistically significant in our null hypothesis. Hypothesis testing is a test of statistical significance, so it is understood. Similarly, if our question is, has there been a statistically significant change in the standard deviation of our process, our null hypothesis would be there has been no change in the standard deviation of our process from its historical value. And if we say this experimental medical treatment has a statistically significant effect, our null hypothesis would be this experimental medical treatment has no effect. Note that our three examples of null hypotheses on the previous slide used the words no difference, no change, and no effect. I've found that it's easier to try to use one of these three options when framing a null hypothesis. The null hypothesis is a statement of nothingness or absence. In words, it is stated in the negative, but the clearest option may be to avoid the use of words completely. As key to understanding number 3 says, it is probably less confusing and more precise to state the null hypothesis as an equation or comparison formula. This allows us to avoid the confusing language of non-existence. For example, instead of saying there is no difference between the mean of population A and the mean of population B, we can just write mu sub A equals mu sub B, where the Greek letter mu is the symbol for mean. For the null hypothesis, there must be an equals in the comparison operator. That is, it must be either an equal sign, a less than or equal to sign, or a greater than or equal to sign. Remember, we state the null hypothesis in the first step in the hypothesis testing method. The sample data has not yet been collected. So at this point, we don't know, for example, whether the mean of sample A is larger than the mean of sample B or vice versa. In many cases, we don't care. For example, let's say we are comparing the means of two treatments. If there is a statistically significant difference, we'll use whichever treatment has the higher mean. In that case, we will use an equal symbol in the null hypothesis. When the null hypothesis has an equal sign, then we have a two-tailed, also known as two-sided test. The value we select for the significance level alpha is divided by 2, and the two halves are placed under the left and right tails of the probability distribution of the test statistic. Common test statistics are z, t, f, and chi-square. For using statistical software or tables, we'll need to specify whether the test will be one-sided, right-sided, or left-sided, or if it will be two-sided. If the null hypothesis does not have an equal sign, then the test is one-sided. But which side is it, right or left? That brings us to key to understanding number 4. Often we do care about the direction of the test. We have something that we maintain and that we would like to test statistically. For example, we maintain and we would like to prove that our new process has a significantly lower standard deviation than the old process. So what we would like to maintain is sigma sub new is less than sigma sub old. Or we maintain and we would like to prove that our school's mean test scores are significantly better than the national average. Mu sub school is greater than mu sub national. Back in KTU number 2, we said it was less confusing to start with a question or a positive statement and then derive the null hypothesis from that. That was for a null hypothesis with an equal sign. Similarly, for null hypotheses without an equal sign, it is more natural to start with what we maintain or want to prove. This is the alternative hypothesis, which is also known as the maintained hypothesis. So we start by stating the alternative hypothesis as shown here in column 1. Then we take the opposite of the alternative hypothesis and this becomes the null hypothesis, as in column 2. We said earlier that if the null hypothesis had an equal sign, then the test was two-tailed. Otherwise, it's one-tailed, also known as one-sided. And the alternative hypothesis tells us whether it's left-tailed or right-tailed, as shown in columns 3 and 4. The comparison symbol for the alternative hypothesis points in the direction of the test. It would have been confusing to start with the null hypothesis and try to remember that the tail is in the opposite direction. It is easier to remember that the alternative hypothesis is what we maintain and what we start with, and that it points in the direction of a one-tailed test. There will be a separate video on the channel on alternative hypothesis. Key to understanding number 5 says, the last step in hypothesis testing is to either reject the null hypothesis if p is less than or equal to alpha, or fail to reject the null hypothesis if p is greater than alpha. Someone once said that hypothesis testing is the reason that statistics is called sadistics. These two test results have caused much confusion on the part of people new to statistics. Even some very experienced practitioners say they need to think carefully when they deal with them. That is why each of these two test results has a separate article in the book and a separate video on the channel devoted to it. But very briefly, the null hypothesis is a negative statement. There is no difference, change, or effect. If we reject the null hypothesis, then we have a double negative. There is not no difference, change, or effect, which is to say that there is a difference, change, or effect. And fail to reject the null hypothesis is a triple negative. Fail and reject cancel each other out. This leaves us with the null hypothesis itself. There is no difference, change, or effect. Okay, that's it for our clarification of this confusing concept. If you liked this video, please remember to press the thumbs up like button on your screen below. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can learn more about those on the website statisticfromatozz.com. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me that more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website has a listing of the current status of available and planned videos. I'd recommend following my blog. I've got some posts there that hopefully you'll find interesting, like a Statistics Tip of the Week series, as well as posts showing that you are not alone if you are confused by statistics. I'll also be posting on Facebook and Twitter. Till next time, I'm looking forward to hearing from you.